Hello and welcome to the subject Geology and Geotechnical Engineering. The subject of today, I'm going to deal with the earth processes. Before to enter the subject of today, I would like to define what is geology, what is geotechnical engineering, and what is engineering geology. Regarding the geology, geology is the earth science that study earth structures of rocks, soils, and composition of minerals. Geology is also studying interior and exterior processes that shaped our planet Earth throughout its history. Geology is studying earth materials and energy resources to be used in human society. Geotechnical engineering or geotechnics is it's a branch of civil engineering concerned with the behavior of the geological materials as rocks and soils. Geotechnics uses the math principles and methods of rocks and soil mechanics. Thus, geotechnics finds solutions for building engineering and foundation design of engineering structures. The geotechnics depends upon the knowledge from math, physics, geology, hydrology, and also geophysics science. The engineering geology. The engineering geology is a science studying both geological and geotechnical engineering structures. An engineering geologist can have a civil engineering or a geology education or both together. An engineer geologist is the man in between geotechnical engineers and also the geologists. Now back to the subject of today, which is the earth processes. The earth processes can be divided into two types, the internal processes and the external processes. These processes are affecting our planet Earth at the same time. These processes are also responsible to rebuild the geological structure at the surface of the earth and also demolish them and destroy them and rebuild them again, also the materials of the geological structures. Let us look at these processes and we will surely understand more about what we mean about these processes. So the earth processes can be shown up into two types of processes: the internal processes beneath the crust of the earth and the external processes at the earth surface. Regarding the internal processes, they can be defined as they are the driving forces that raise mountain chains and cause earthquakes and volcanic eruptions. To explain that, we may look at the following image. The following 3D the image show us two types of plates, which are the continental plate here, showing here, which are representing our continents at the surface of the Earth and above the sea level, and we have the oceanic plates, which representing the part of the crust beneath the sea level and the also which the sea or ocean's floor is also there. So we have the first part of the continents. The oceanic continents are active and can give us also give us energy for the internal processes. Well, the most common energy which the internal processes are working with or active by it is the convection current. The convection current are there because of the movement of the materials composing the mantle of the Earth, and these materials are dissolved rocks, magma, flowing materials. They can also move around the core of the Earth and make circulation movement. This circulation movement can also move the upper part of the upper part of the Earth sphere, which is the crust of the Earth. The crust of the Earth, as mentioned before, usually is in two parts: the continental plate and the oceanic plate. Regarding the oceanic plate, there are some ridges or spreading area at the oceanic plate. The spreading area, we call them the mid-oceanic ridges zone, which is a zone along the there are some volcanic and also earthquakes activities, and this happens due to the materials come up from the mantle of the Earth to be explode as volcanic eruptions, and these volcanic eruptions can add, of course, materials to the reef area or the edge area of the continental of the oceanic plate, and these materials can accumulate and make huge volcanic rocks structures that can also affect in eastern to the size or to the edge of the oceanic plate to be moved apart of each other. So the oceanic plate can move apart from each other at the spreading zone or the mid-oceanic ridges zone. So we can also imagine that the material, the rock material that come up from the volcanic eruptions are newer than the materials at the far away from the spreading zones. So the material here or the rocks here can get the age of Neogene, which is our modern time, and the rocks here at the end of the area can give us ages of Jurassic, Triassic, Cretaceous, which are old enough about 200 to 300 million years. So the the difference in the time can also be distinguished in the oceanic plates rocks. Usually the rocks that composing the oceanic plates are basaltic, mafic, and heavy minerals rocks. The other type of the collusion, or the area that composing earthquakes, is the collusion area between the oceanic plate and the continental plate. These collusion areas are affecting to each other and destroying the edges of the plates. So the surface area here between the two plates is deformed, is composing from deformed rocks, and these deformed rocks, we call them usually the metamorphic rocks. And the metamorphic rocks can show up in two types. The first type is a contact due to the temperature, the huge temperature they've been opposed to in this area, and the other type is the pressure metamorphic rocks, which are deformed and folded due to the huge pressure they have been affected for. So these two types of continental or metamorphic rocks can show up to the surface of the earth, and we can also distinguish which type of metamorphic rocks are there. So the contact type can give us also stripes of different minerals, because the temperatures, the high temperatures, give opportunities to mineral to be also gathered together within the rock mass. While the other type of the metamorphic rocks, they are also accused to the huge pressure, where there are no time for the metamorphic minerals to be separated and give us the different striping masses or different striping pattern. So we have the area between these two plates is active and can also give us some types of folding to the continental edge, and this type of faulting sometimes can be released and give us an energy back to the waters that covering this area. This mass of water can move up and down the oceanic water, of course, and from this moving up and down, the water masses can also produce a type of circulation, a wave circulation, and this wave circulation, when they come near to the shoreline of the continental plate, can be shown up as huge intrusion, water intrusion to the continents area, which we call them the tsunamis. So there are also some, and this, of course, this movement for the continental plates can show up as earthquakes without volcanic eruptions. So we have the other type of earthquakes and volcanic eruptions comes up due to the subduction of the oceanic plate. The subduction of oceanic plates means that the oceanic plates can go down to the mantle of the earth, where there are a huge temperature and pressure affecting these rocks, the oceanic rocks which are there, and being dissolved to the same type of the earth or the content of the mantle. The dissolved materials are still having different materials and densities than the materials composing the upper part of the mantle. So these differences of the densities can give us some a type of accumulation to or gathering to the materials, and these materials can come up again due to the differences in the density of these materials, and being uplifted to come up again to the towards the beneath the continental plate. And when they are near to the continental plate and collision happens between these masses to the beneath areas of the continental plate, and these collision can give us earthquakes without volcanic eruptions. So far as we have this material here, this material can find also a way to come up to the earth surface, and this material can show up as volcanic eruptions and come up through the dikes, the seals within the continental plate to show up as volcanic eruptions, and these volcanic eruptions, of course, are coupled usually with earthquakes. The other area which are also active in earthquakes and volcanic eruptions is the area which is some regional faults or breaking can take places here in the continental plate. And these areas are usually a collision area between two continental plates. So the area between these two continental plates were a precipitation basin, and the precipitation basin has been closed together due to the huge amount of pressure the oceanic plates give to the continental plate. And just imagine that there are another oceanic plate in this side here, and this can give us two squeezing forces to the continental plate, and the continental plate can be moved up and rise up or uplifted from the sea level. This uplifting can give us also some movement and breakdown to the solid rocks of the continental plate. And of course, these forces can also push the continental plates and close the precipitation basins, and the precipitation basin can, the materials in the precipitation basins, the rocks materials can show up as huge mountain chains, and these mountain chains can be at many incidents sedimentary rocks. An example of this type of examples of this type of mountain chains are there, just like the Alps, which are the collusion or suture line between two continents. The oceanic continents is this type, the oceanic continents, the Middle East continent, and the Mediterranean continent, and we have the European continent, the north west of part of the Eurasia continent. And we have the other type of mountain chains, just like the Taurus, the Zagros, the Alps, and so on, are also, especially the Taurus and Zagros, are a collusion area between two continental plates. And the high mountains there representing the uplifted material from the precipitation basins. The other type of, there are also volcanic and earthquakes activities when there are opportunities for the materials in the mantle to come up within the regional faults in the continental plates and show up as volcanic eruptions and earthquakes. So these are the internal processes that can destroy and can be destructive processes, can be demolished processes, and at the same time can be also rebuilding constructive processes to the geological structure at the surface of the earth. The other type of processes, we call them the surface processes or the external processes. And the surface processes are those processes that sculpt, erodes the surface of the earth, and the most of these surface processes are driven by water, wind, glacial ice, or human activities. The physical processes or physical elements can also be a part of these processes, such as the gravity of the earth, the density of the material, the temperature of the atmospheric temperature, and also the temperature of the water of the precipitation basin, and also the magnetic field of the earth can be significant processes and properties to give energy to the surface processes. And to explain what we mean about the surface processes, I'm going to present this image. And this image has been produced at the late of 90s, which I produced this image, and then I can also explain what we mean about the surface processes of the earth. The following image show us some zones, and the most important zone here is in the surface processes is the atmospheric processes or the atmospheric activities of the that affect the surface processes. So we have the atmospheric activities represented in the differences in the atmospheric pressure and atmospheric temperatures. There are, of course, different temperatures between two positions at the surface of the earth, and the difference in the temperatures give us also differences in the atmospheric pressure, and that make the wind that or the gases in the atmospheric place to move from a position to a position, and sometimes this movement can be huge enough to show up high velocities, just like show up as storms and hurricanes. And this huge energy, atmospheric energy, can destroy the pre-existed rocks. And the pre-existed rocks here are showing up because they are they can also be affected by the weathering processes and the raining and the snowing and also the wind blowing processes. So the pre-existing rocks are showing here in this diagram. They are also showed here in this 3D diagram. The pre-existing rocks are rock that been affected by the atmospheric activities, and these rocks can be break down to smaller parts and been also weathered, eroded, and transported from the from a position which is the from the first position, which is the pre-existing rock, to another position which is having lower altitude, which means that from the highlands here to other position which can be lower position or near to the sea level. These materials can be transported, of course. The pre-existing rocks weathering results materials can be transported within by the means of the streams, rivers, wind, glacial activities to the basins, and these basins we call them the precipitation basins, where the materials of the weathering can be more stable there. So these precipitation basins are showing here. They are also showing here in this diagram, precipitation basin, and they are also showing here between the two continents, two parts of the continental plates parts, which can be close together and give us folded mountain chains up to the surface of the earth. So the precipitation areas are also divided into zones. The uppermost zones, we call it the suspended material zones, where the materials are fine enough to move at the surface of the ocean's water. When these materials have opportunity to collect together and accumulate together and be attracted together by the ionization, for example, of the materials resulted from the weathering processes, they can be gathered at the in a zone below the suspended zone, which contains particles are big enough to be affected by the temperature of the water basin, by the pressure of the water column, by its materials density, and also being attracted by the earth gravity toward the toward the center of the earth, and also the earth magnetism also has significant effect on these materials. So we have the all these properties, physical properties, affect the materials in the precipitation zone to be more stable and began to move to the more stable zone, which is the deposition, sedimentation, and compaction zone. In this zone, there is a process started there, which we call it the solidification processes, where the materials being compacted together and solidified to appear as rocks, sedimentary rocks. This type of rocks can be affected in 2 or 3 ways. The areas here in this area, the solidified rocks, sedimentary rocks, can be moved with the subducted zone to be dissolved here in the mantle and come up again as volcanic eruption. This we call this process the circulation, or the rock circles, or the circles of the rocks. So we have the other type or other part of these materials, the precipitated materials, can be a part and compose the metamorphic rocks at the zone of the collision zone between these two plates. The third part of these materials can show up again as a folded area to the surface of the earth and makes mountain chains area. And if these basins are in this area between the openings between the two continental plate, these materials can show up again as a folded area, and we call them usually the suture lines between two collided plates. Lastly, I would like to say that builders, engineers, and city planners might consult geologists if there are probabilities for earthquakes or volcanic eruptions at the chosen area of the engineering structures. So if whether it is a normal family house or a collection of houses, family houses, or a huge connection bridge between two islands, and or a skyscraper should be built there, or a water dam. All these projects should be studied, or the ground of this project should be studied before to start building an engineering structure there. Lastly, I would like to present some conclusions for the subject of today. The interior and surface processes are important and must be considered whenever an engineering project should be built. And the effect of these processes can damage geological structures as well as the engineering structures at the surface of the Earth. The planet Earth suffered during its history from both destructive or demolishing processes and constructive or rebuilding processes to the geological structures throughout its history. The earthquakes resistance structures and elements must be considered and used in the geotechnical foundation design, whether it is a family house or a huge engineering project. We should study the effect of the surface processes before starting building and engineering structures. Lastly, my name is Sabah. I am an engineer geologist, and the next presentation will deal with the Earth spheres. And lastly, I would like to thank you for watching this presentation, and please give us a thumb up, like, share this video to your friends, subscribe and click on the bell below. That will help us and encourage us to go further making these informative presentations videos. So please also do not forget to write your comments to us and ask us your questions. We will be happy to answer them, and also use your comments to present better presentation videos in the coming future. Thanks again for watching, and take care.